So let's talk about how to use counters from 8051 microcontroller, and this program which explains how to display count value based on counters programming. So just I am using Keil and Proteus combination for this. Just double click on Keil Microvision and select project tab and choose new project. So and save your program in a specific drive and choose the drive and go for your specific folder. Now my folder name is a learning room. So this is my project name. I just want implement counter feature from 8051 microcontrollers, so my project name is counter, and click on save and select the device from different manufacturer, which is Atmel. And choose the device from manufacturer, which is Atmel, and just click on this plus mark. It will extract all the devices from this manufacturer. Choose a specific device, which is 8089C51, and click on OK. And this is a startup code warning. Click on no. And now go file tab and open your new editor, this editor window which allows to write your program. Save this file. For that, go file tab and choose option save and give your program name with .c extension. Click on save. So this is the header file for 51 families, and I'm using 2-digit 7 segment. So I have to control the common lines of 7 segment device, and I'm connected with a specific IO pin, which is P1.0, and the second segment common pin, which is connected with other IO pin, which is P1.1, and data lines which are connected to port 2. So now you can start your main from here, and you have to save all the values related to this segment from lookup table, and just minimize this, and this you have to prepare from lookup table. So these are the equivalent hexadecimal values. I am just copying into the program, which allows to save the values. So these are the 10 values. C0, which allows 0 on common anode, and F9 for 1, A4 for 2. So this will continue up to 9. So these are the hexadecimal values you have to assign to get the display on common anode 7 segment. And so you have to follow the steps related to counter. So by using tmod register, and you have to write all SFR registers in capital letters in Embedded C program. So and you have to assign the equivalent value to display 99 00 to 99. So I can choose with mode 2. So and now I am selecting counter 1 in mode 2. So the equivalent value is 0xC0 60. Sorry. And next, the TL1 value, which is by default, which is zeros. So make sure just I am clearing this TL1 value, which is 00, and start the counter by making TR1 bit as 1. And you have to monitor this TL1 register value continuously. If external pulse you will get from outside to the counter, so it will increment the value by 1. For one high to low pulse, it will increment one value in TL1. Just maximize this window, which will show the clear. And so these are the steps you have to follow to deal with counters. Now I'll keep this entire process in while loop. So to read this TL1 value, I'll declare one temporary variable with a character data type. V1. So this V1 value, which will read the value from TL1 register, and I just want display. I want to wait some time to see the display with. Otherwise, so anyway, you have to maintain some delay between each segment. Either you can choose integer data type or character data type with a wait. And initially these two common lines, which are zeros, and data lines, which are all zeros. Now, so you have to read the value from TL1 register. Whenever you are applying one external pulse, the value in V1, which will increments by 1. So V1 is equal to TL1. So this V1, which gives hexadecimal equivalent. So but you are expecting 2 digits 7 segment. If it is 0, you have to display as 00 from your segment. If it is 0x01, you have to display two individual numbers on two segments as 0 and 1 separately. So how to separate this V1 value as 2 digits? So for that, I'll take another two variables, so which are V3 and V4. So now what I will do with this V3, so just I am masking the LSB value of V1 and operation with 0x0f. So now this V3 value, which will give me the low LSB bits of V1, which is separated by masking this V1 value. And what is V4? So this V4, I'll do AND operation with 0xf0, and after this I'll do rotate shift 4 times. So because of this, I'll separate one 8-bit value into two parts. So suppose it is 22. So 2 is saved in V3 and 2 is saved in V4. So now I'll display this value by activating segments. COM1 is equal to 1 and COM2 equals to 0, and see the value what I am giving to this port 2 display of V3, and maintain a proper delay which is very less between two segments. So as per program, you will give some 500 up to. After some time delay, so I will switch to the second segment by disabling segment 1 and I'll activate segment 2. And this segment allows the next digit. This is from V4. So now give the value of display of V4 and give the same time delay between each segment. So if the value is 0x00, now 0, it will extract the element display of 0 means it will extract C0 from this array. And if even second segment also 0, which will extract the same number from lookup table. And to repeat this, try to turn off segment 2. So this process I am going to do continuously to count the pulses by using counter 1 in mode 2. This I'll show you output with Proteus simulation by creating hex file. So this process is for compilation. Select source group 1 and choose option add files to source group 1. Now my program is counter and click on add and close. So there are two errors in my program segment, these are common, right? So I made name as COM and even this is also. This program which will count the pulses from outside by using counter 1 and create hex file to see the output with Proteus simulation. And in the same window select output tab and click on create hex file and choose option OK and build it. So now which creates hex file equivalent for this, and minimize this and open your Proteus tool to simulate this output. And for my application requirement I need one microcontroller and 2-digit 7 segment further type the keyword 7 segment and you can go for different colors which are available here, and now I am choosing red. And to apply the pulses I'll take one simple button and arrange the circuit with Proteus simulation. Click on button and you have to connect your button at counter 1 source which is T1 from microcontroller. And as per program just go through your assumptions where your common pin connected and where your data lines connected. So common lines which are connected with P1.0 and the second common line which is connected with P1.1 and data lines which are connected with port 2. And now connect your pulse source with T1 pin, and if it is not visible just zoom it. And now connect ground pin by choosing terminals mode, and this is the source. Now connect your terminal 1 with this switch other terminal. And this is the hardware connection required to test the output. Now double click on the controller which will ask X file path which is present in D drive and folder name is learning room. Now choose your hex file which is counter open and give the oscillator frequency as same as with how much frequency you created hex file, and click on OK and play the simulation. Now which is showing 0 0, and if you are applying one high to low pulse, yes, so you have to change this as segments common lines. So as per our assumption, the first segment, which is V4, and second segment is V3, and now play it. You'll get 0 0, and for one high to low pulse you'll get change in the count: 2 3 4 5 6 7 8 9 10. So something is wrong with the values in the program. So otherwise, change this conversion process as V1 divides with 10 and V1 a remainder with 10. So then you'll get accurate output. So now we just set right it to this V3 and V4. Stop the simulation and replay it. For one high to low pulse, you'll get change in the count, and so you can observe the count very clearly. For one high to low pulse, you'll get the change in the count exactly. So this is the program. You can count up to 99 pulses by using counters from microcontroller. So this is the program by using counters, and this is the only process to separate one hexadecimal value as 2 digits. So if V1 is 0x25, by dividing 25 with 10, I will get remainder as quotient as 2 and remainder as 5. So this V3 will store quotient and V4 will store remainder. So this you will find it. I'll comment it. This is to easy understand. So what I'll get from this process. So one 8-bit value which is divided into 2 parts. So I'll show you the simulation which is running exactly. So for this you can count your values up to 99. So this counter program which allows the pulses from 0 0 to 99. So this is the output of counters. Thanks for watching.